Today we're going to be looking at tutorial 1b, where we focus on a simple optimization problem in a single variable, interpreting the solutions and graphs of the functions and solutions. Agent with an opinion sigma about the policy issue S, and assume this agent has a utility of opinion utility, which is a function of sigma, is given by utility, which is a function of sigma, is equal to eta sigma minus pho over 4 bracket sigma squared minus 1 all squared, for pho is greater than 0. We assume that the agent chooses the opinion that maximizes their utility. The first question is asking us to calculate the opinions when the agent has no evidence, i.e. when eta is equal to 0. So if eta is equal to 0, we get a new utility function which looks like minus pho over 4 bracket sigma squared minus 1 all squared. So this first term disappears. To work out the optimum values, we're going to have to differentiate, but before I do that, I'm going to expand the brackets so that we get utility function is equal to minus pho over 4 sigma to the power of 4 minus 2 sigma squared plus 1. If I now differentiate this, we get minus p over 4 brackets 4 sigma cubed minus 4 sigma. If I differentiate this again, we get minus pho over 4 12 sigma squared minus 4. And this is going to be helpful for finding whether our opinions are maximums or minimums. If I now begin by working out the optimum opinions, we're going to have to equate the first derivative to 0. So we get 4 sigma cubed minus 4 sigma is equal to 0, as we can just divide by the minus p over 4 when it's equal to 0. One of the solutions will be sigma is equal to 0, as when we divide by sigma, that solution gets removed. So we're left behind with 4 sigma squared minus 4 is equal to 0. So sigma squared is equal to 1, therefore sigma is equal to plus or minus 1. So we get 3 solutions, minus 1, 0, and 1. When we now sub in these solutions into the second derivative, we can tell whether they're maximums or minimums. When we sub in 0, we get a positive value for the second derivative, so 0 is going to be a minimum. When we sub in 1, we get a negative value for the second derivative, so that means 1 will be a maximum, and this is the same with minus 1 as well. Moving on, we now need to sketch this utility function for when eta is equal to 0 and explain our answer to the previous sub-question using our sketch. So when we sub in 0 into the utility function, we get minus p over 4, which I will put over here. When we sub in minus 1, we get 0, and when we sub in 1, we also get 0. And we know that these points are maximums, and this point is a minimum. So our curve looks something like this. Now, for the explanation, I'm going to say when sigma is equal to 0, the agent has the lowest utility, and when sigma is equal to 1 or minus 1, the agent has the maximum utility. And what we can also say is the agent is indifferent between a positive and negative opinion. Moving on, sketch what happens to the agent's optimal choice if the agent would learn about a very small amount of evidence, eta is equal to 1 over 5, and comment on how the agent might change their opinion. So now we have a new utility function, which will look like 1/5 sigma minus pho over 4 sigma squared minus 1 all squared. When we sub in sigma is equal to 0 into this equation, we get still minus p over 4, When we sub in 1 into this equation, we get 0 minus 0.2. So that would go here. And when we sub in positive 1 into this equation, we get 0.2, which would go over here. So we get a curve looking something like this. Some comments that we can make about this is when the agent considers evidence, his utility is maximized when he has a positive opinion. Moving on. Number 4, agents with a security. Consider an agent who earns 4 units of income during their working life and who will receive a state pension of 2 units for their pensioner's life. Assume this agent has a utility of consumption given by this equation, where their consumption in each period is given by this equation and this equation. P is the unit cost of the private pension and X is the gross return of that private pension of the retirement. We assume that the agent chooses to buy H units of private pension that optimizes their total utility of consumption. Our first task is to sketch the total utility of consumption of the agent as a function of the number of private pension units they buy. So first, let's write down this utility function using all the information that is given to us. We get utility function is equal to log 4 minus 1/3 h plus 4 over 5 log 2 plus 3 over 2h. If we now sub in various values of h into this equation, we will get the coordinates that we need to plot. Let's start with h is equal to minus 1. We get 0.9, which is roughly around here. When we sub in minus 0.5, we get 1.6, which is roughly around here. When we sub in positive 0.5, we get 2.13, somewhere around here. When we sub in 0, we get 1.9, somewhere around here. And when we sub in 1, we get 2.3, somewhere around here. So we get the curve looking somewhat like this, if I'm not wrong. Okay, part B. Calculate how many units of private pension H the agent will buy during their working life. The agent will want to maximize the number of units he buys in order to maximize his consumption. So we're going to have to differentiate our function that we had before. Over here, when we differentiate this, we get minus 1/3 all over 4 minus 1/3 h plus 4 over 5 times 3 over 2, 2 plus 3 over 2h. If I now equate this to 0 and move this to the other side, we get 1/3 4 minus 1/3 h is equal to 12 over 10, 2 plus 3 over 2h. If I now cross multiply this, we get over here 2 over 3 plus a half h is equal to 24 over 5 minus 6 over 15h. If I now solve for h, we get 9 over 10h is equal to 62 over 15. So h is equal to 124 over 27. If the gross return x of the pension plan is lower, i.e. x is less than 3 over 2, how does the agent buy more? Does the agent buy more or less units of the private pension? He will buy less as they have less of an incentive to buy the private pension, as it gives a lower return. Cool.